Prime factors. Let's draw a factor tree for the number 36 and then use that to find the product of its prime factors. So first, the number tree. To make a number tree, we start with the number which we're trying to make one for, which is 36, and we draw it at the top. So now it's up to us to decide what we're going to divide 36 by. So we're going to take two factors of 36 and split 36 up into those two values. We have a choice here because there's a few factors for 36. So let's just pick two. Let's say we're going to multiply 4 by 9 to get 36. So here are two factors of the number 36. So the reason this is a tree is because you just keep doing this until you're reduced to the lowest values where you can't go any further, which are actually prime numbers. So we take the number 4 and we find two factors. Right? What two values do we multiply together to get 4? And for us, this is going to be 2 and 2. So you're not allowed to write 1 and 4 because you'd just be writing 4 again and that would just go on forever. So it has to be any value greater than 1. In this case, 2 times 2 gives us 4. And in the same way, over here for 9, we have to find two factors of 9. So they are 3 and 3. So we can't divide 2 by anything more, we can't divide 3 by anything more because these are all prime numbers, right? So what we have here is a tree, and this tree, once broken down, gives us the prime factors of the number 36. And so we can actually write the answer for 36 and its prime factors as a multiple of these. So basically 2 times 2 times 3 times 3 equals 36. That's what we've deduced from our factor tree. And so since we have two 2's, we can actually rewrite that as 2 squared. And we also have two 3's, so we can write that as 3 squared. And we have the two 2's multiply right here by the two 3's, so we still have that multiplication sign there. And then that also equals 36. So 2 times 2 times 3 times 3 can be rewritten as 2 squared times 3 squared. And that is the product of prime factors for the number 36. Let's express 102 and 60 separately, so this is two questions, as the product of its prime factors. So we just learned how to use a number tree, so let's do that for these numbers. Sometimes these trees go on a long way, and sometimes they're actually quite short. So 102, well, this is an even number. So let's choose to divide this by 2, and 2 times 51 will give us 102. So there's our first set of factors. 2 times 51 equals 102. 2, we're already down there. It's a prime number, so we have to look at 51. So can we divide 51 by two values? Can we find two factors for the number 51? We can. It's 3 and 17. 3 times 17 gives us the number 51. And these are both prime numbers. So this tree is actually pretty small. So if we're going to write out the product of prime factors for 102, we say that 2 times 3 times 17 equals 102. That's the product of its prime factors. 2, 3, and 17 are all prime numbers. Let's look at 60. So there are different ways. You'll have different trees, but they'll reduce to give you the same number. 60, for instance, I mean, we could choose to divide that by 10 and 6, or we could write 4 and 15, or we could do 2 and 30, right? So you can start them in different ways, but they will all reduce down to give you the same product of prime factors. So let's just pick 15 and 4. 15 times 4 gives us 60. 4 we can write as 2 times 2, and then that is two prime numbers there. 15, we can write that as 3 times 5. And those are prime numbers there. So if we're going to write 60 as the product of its prime factors, we have 2 times 2. Okay, so like in our first example, that is 2 squared. And we multiply that by 3 and multiply that by 5, and that gives us 60. Now we have a number. It's expressed as a product of its prime factors. We have 2 cubed times 3 squared times 5. And what is that number? So we have to figure out what this number is. So the easiest way to do that is to simply write this multiplication out. So we have 2 cubed times 3 squared times 5. So let's write this out. 2 cubed is 2 times itself 3 times. So we have 2 times 2 times 2. And that multiplies by 3 squared. So 3 times itself twice. So 3 times 3. And that multiplies by 5. So we write 5 here. So this 2 cubed times 3 squared times 5 looks like this. If we write it out, and now we can figure out what we have here. So 2 times 2 is 4, 4 times 2 is 8, 8 times 3 is 24, 24 times 3 is 72, and 72 times 5 will give us 360. Okay, so if you needed to do that one, 72 times 5 does get pretty large. You might have to do long multiplication off to the side. 5 times 2, 0, carry the 1. 5 times 3, 35 plus 1, 36. That does indeed give us 360. That's fine. If you want to do that off to the side, no problem. If you could do it all in your head, then you'll get straight to the answer, 360.